In this segment, we'll see how to use ExpressionSuite to set up a study consisting of one or more delta-delta-CT real-time run files. We'll start by launching the software. To do this, either double-click on the icon for ExpressionSuite, or if you have a Quant Studio, simply go to the software's home screen and click here. Once on the home page, we find a list of previously created studies. That's because when we create a study in ExpressionSuite, it gets saved to the application workspace specific to that particular installed copy of the software. If we want to open a study from the list, we select it and click Open Study. Deleting a study from the application workspace works similarly. Highlight, delete study. The Transfer In and Transfer Out buttons allow users with different install copies of ExpressionSuite to share study files. So say we want our colleague to have a copy of this first study. We simply select it and transfer out. Then save it to a location such as to a thumb drive or someplace on our hard drive. We can then either share our thumb drive with that colleague or send the file through email. Now once the colleague has that file, he or she hits Transfer In, navigates to the folder where the file is stored, selects it, and opens. And now it's stored in their copy of the software. Finally, starting from the home page, we can create a study. That's what we'll be doing for the rest of this video. We begin by giving the study a name. Next, we choose the type of instrument that our run files were generated on. This is an important selection for two reasons. First, if we choose an instrument type that's different from the file we subsequently try to import, we'll get an error message. Second, studies only accept multiple files from a single instrument type, so no mixing, say, Step 1 Plus and 7500 experiments. We may add a description of the study if we choose, as well as any comments. Now, this latter field warrants some further explanation. We type our comments either before or after analyzing the data, then click Add. Our remarks are then permanently attached to the study file along with our username, the date, and time of entry. We can add more comments later on, but we can never modify or delete comments after we add them. Also, note that the username is the rather generic guess, and that's because we haven't set up auditing and security features yet, so the software has no idea who we are. That'll change in video number 5. Let's now go under the Setup menu and select the next menu option, Experiments. Here's where we add specific real-time experiments to a study. First, click the Import button and navigate to the folder containing the run file or files. Select them. We'll do 2 via7 files for this demo, and click Import. Now, not just any files can be combined. I already mentioned the restriction that files must be from a single instrument type. In addition, all experiments need to share the following characteristics: same thermal cycling parameters, including the reaction volume, the same passive reference dye, and all files need to have been analyzed using the same algorithm, either baseline threshold or relative threshold, prior to being saved and imported into ExpressionSuite. We can always delete an experiment if we choose. Simply select and delete. Before we do anything with these icons at the top of the screen, let's go to Samples and Groups. The sample names we entered in the original real-time run file import automatically into ExpressionSuite. We can go back and change these in the original files if needed, then save and re-import. However, we can't change sample names directly in ExpressionSuite. One thing we can do, though, is assign samples to biological groups. Probably the easiest way to do this is to select all samples that belong to a particular group, click the Assign Biological Group button, type the name here, and select a color. Now, once the biogroups are all labeled, we can go to Targets and Controls. At the top is a list of all assay or target names in the various files we imported, plus the number of wells occupied by each. We also see a column for type, which is the same thing as task in the real-time software. Now, this first gene defaults to candidate control. If we know already that beta-actin is the target we want to use as our normalizer, we can select it, then go under Assign Type and choose Assign as Endogenous Control. We can even assign multiple genes as our controls, that is if we wish to normalize simultaneously to more than one gene. Quickly, here's an alternate way to label. Select a gene, right-click, and choose the appropriate designation. Well, let's say in advance we don't know which one of our gene targets is most stable. Instead, we want the software to tell us. Here's what we'll do. Assign all samples as candidate control. In the lower pane, and I'll click this caret to expand it for the moment, we see each gene and its sample-specific CT plotted as a line. The flatter the line, the more stable the gene is across all samples. To figure out which gene or genes might be good to use as a normalizer, let's look up here at the column labeled Score. These values are based on the GeneNorm algorithm, whereby the lower values imply greater sample-to-sample stability in expression. We need at least 3 genes selected as candidate controls in order to get meaningful scores, though having even more often improves the accuracy of the score as well as the chances that one of our genes will be stable enough to use. Which leads me to this caution. If we only have a handful of normalizer candidates, we need to be careful about simply relying on the scores. It could be that the assay with the lowest score still isn't stable enough to serve as a good normalizer. We need to be sure to go back to the chart at the bottom and look at the actual CT variation. Assuming we start with equal amounts of template for each sample, always a good idea, ideally we'd like to see the fluctuation at or below half a CT. It actually appears in our case that we don't have a stable enough control gene. Even beta-actin seems to be fluctuating a little more than we'd like, but that's okay. This is just an example. Well, let's actually leave this study for just a moment and look at a different one. In this file, we have over 350 genes, a fairly common scenario when we're using TACMan array cards. Whenever we have this many genes, there is another option we might want to consider for normalization, and that is the global normalization, whereby the median CT of all the genes in the study is used to normalize data instead of just 1 or 2. We simply click Use Global Normalization, then the Analyze button, and now there we are. And don't worry, we can always change this setting later if we want to. And that's really it for the setup. The last thing we need to do is save the study into the ExpressionSuite Workplace. To do so, we go to Save As, enter a study name, and OK. When we go back to the home screen, which we can do by clicking here, the new study appears in our list. And that's pretty much all you need to know about the setup process. In the next video, we'll take a look at running a quality control assessment on our combined study data.